Dr. Abhishek is the next speaker. I know him from very ago 2015 when I started my PhD at University of Copenhagen. He finished his PhD from in US and came for a postdoc in Denmark, and then he did another postdoc in Sweden, another postdoc in Singapore, and finally came to UK University of Reading and start his new position as assistant professor in statistics. And today he will talk about Moneyball revisited, leveraging data analytics for competitive advantage in baseball.
So we'll talk about applications of some basic statistics in baseball analytics. So the sabermetrics is basically how statistical data analysis is used in various types of for measuring certain for measuring certain metrics for in a baseball game and things like that. So we'll start with a very basic stuff. We'll start with linear regression, and then we'll go to the actual problem, and then we'll show if time permits, then we'll show some R hangout stuff. So let's start with the simple linear regression. So we know the model. We have the observation y. We x are the covariates, and beta is the corresponding coefficient, and epsilon is the noise, and the least square estimate is basically that. Now, the way we can study the goodness of fit is basically using these two metric, that is R square and adjusted R square. Now, the difference between them is that when the residual sum of squares and total sum of squares in the R square, they come in its own form, but in the adjusted R square, they are adjusted by their degree of freedom. But what it does is very interesting. So if we add a covariate or some interesting additional variable into the x, then what happens that R square always increase. It takes values from 0 to 1, but it always incrementally increase. But it will not tell you the information whether the new added covariate will impact the analysis a lot more than the existing covariate or not. And that is where adjusted R square comes into the picture. If the new covariate added that makes the performance little more than it is expected from the rest, then adjusted R square will increase. So the difference is that adding a new covariate may not always increase the adjusted R square. Your adjusted R square can also decrease even if your added covariate, I mean, you are adding a new covariate, but R square always increase. So we can use this adjusted R square to make inference about a new covariate is useful for inferring, I mean, for making a fit for variable y or not. And we'll see that how this particular information will be helpful in the data analysis. Now let's go back to the problem. This problem is actually came from the famous book written by Michael Lewis, Moneyball, and there is a movie also that goes by the same name. It talks about a particular baseball club. So baseball is a really big thing in United States. It generates lots of revenue, and like in basketball, they have generate lots of revenue in United States. Baseball is no exception. And regarding this club, Oakland Athletics, they have a great history of winning. So ALCS, basically American League of Championship Series or something like that. So they won ALCS from 1989 to 1991. So it's really big thing. And then they won the World Series in 1990, and they had the biggest payrolls in 1991. So everything was going good for them during that time. And suddenly what happens is that in 1995, the ownership of the club got changed, and as a result the payroll got slashed, and the slashed budget becomes a norm for quite a few years. And what happens is that in a capitalist country like in United States, if you have lots of money, then you can buy good players, and you can get good results. But still, even with a reduced budget, they managed to they managed to do very well. So, for example, I'll give you a context. In 2002, they lost their star player Jason Giambi and also two other star players. Even if they lost those two star players, they still made it to the playoff. Playoff means that there are total like around 30 or yeah, something like that. Total number of clubs. Oakland Athletics is one particular club. They participate in a particular league, and the last four in, I mean, sorry, not last, in terms of ranking, the first four, they make it to the playoff. And so in 2002, despite losing their star player, they made it to the playoff. So and also winning 20 consecutive games. So how they made it happen? So this is, you can see that how winning or ever winning is affected by the money they spend on salary. So average yearly salary for every club. So each dot represents each club, and from 1998 to 2001, in x-axis we are plotting the average yearly salary of that particular club, and we are on y-axis we are plotting the average yearly wins. So you can see this blue dot. Of course, they spend like average yearly salaries like 90 million. The blue dot stands for the New York Yankees club. So they had a lot of funders, lot of sponsors, rich sponsors, and they also managed to get very good results as well. You can see close to 100% winning rate. And this red is stands for Boston Red Sox, another famous club, very rich. In this whole scenario, the only outlier is this green point, and this green point is basically Oakland Athletics, and their average yearly salary is less than 30 million, but average yearly wins is close to 90%. So how they made it possible? And that is where their manager Billy come into the picture. And actually it is not the story of the manager. I mean, his role was played by Brad Pitt, and it was extremely celebrated in that particular movie. But the interesting thing that Billy did was that he hired the right person, and he was a that person called Paul De Podesta, and he's the analyst, and he was I think he was an economist, and he did something very simple thing like linear regression for scouting new players in limited budget, and they made the success story happen. So let's give you some type of problems like what he did. So, for example, suppose place yourself in the position of the general manager of a team, and you want to select two players for your team, and you have a budget of 1.5 million, and these are the players that you have. So I'll tell you what these things are, and these are technical terms. This is called on base percentage, and this is called slugging average. And I'll tell you these are the two important quotient of a particular baseball player that actually makes them valuable. So on base percent, and okay, so these are their salaries, and these are their on base percentage and slugging average. Out of this thing, how can you select two players? So that is the problem that we'll eventually solve. Now let's tell like what previously used to happen. So all the scouts, they used to go to the local football baseball club, and they used to select players based on this batting average. And the batting average is basically the number of hits divided by the number of at bats. And if you break things down, it is the number of hits is H. And then there are also additional stuff that you miss. So AFC, which is called failed chance, and then out, and E, I forgot the term, but those terms. So this was the ratio that people used to take when they're selecting the new recruits of baseball players. What Paul De Podesta did was that instead of having this batting average, he used these two particular metrics, on base percentage and slugging average. Let's see what is the on base percentage. It is the ratio that how often a batter reaches base. So it is, so not only a efficacy of a baseball batter is measured based on how much he can hit, also he can hit and also he can reach to the base, so which are dependent on these two quantities, W and HP. So HP means hit by pitch, W is walks. Number of hits, walks, hit by pitch, and then in the denominator you have AB, and this walk, hit by pitch, and SF basically means I think sacrifice flies. So you see H by AB is still there. Along with that, you have some additional information is there, and that is on base percentage. So that is the difference that of that from the batting average. And slugging average is literally the how effective that batter is in hitting scores. So it is like very similar to strike rate in cricket. So it is total bases divided by total number of at bats, and that is basically this ratio. Okay, now I'll come to the can you see the hangout? uh, Hello.
Yes.
Okay, thank you. So basically, there is a data set that I had. If you can see, a baseball data set, and this is available in Kaggle. This is available in other, I mean, online as well. And this is a very famous baseball data set that is available in the internet. Just search it, and you'll get this Excel file. It's not very difficult to get. And so this, let's study this data set. So I have this dataset in that particular folder, and then I use these comments in R, basically reading that .csv file and make this summary of this dataset, and that will give me the list of the variables. So team is basically the short name of the teams. League is basically whether they are playing the National League or the American League. So these are the two types of league they play, the year they play. So we have the data from year 1999 to 2012. So lots of years of data we have for each team. For so there are, you can see that there are okay, so I can't see how many teams are there, but yeah, so from 1999 to 2012 is the total number of years that we are having. Then total number of games is this quantities, and total number of wins is W. Total number of runs scored by that team in that particular year in that particular league is basically RS, and run against is basically total number of runs they defended that particular team in that particular league in that particular year. So that is run against. Now this on base percentage and slugging average for each team is measured given there. Now, let me tell you. So previously in the slide, I told you the on-base percentage of a player. But here, this on-base percentage is basically aggregated in a all the players in that particular team. So this is like aggregated on-base percentage, aggregated slugging average for every team in a particular league, in a particular year, and so on. Then there is batting average is also there, that is also aggregated batting average. Every measure here after this OBP, they're all aggregated stuff. Now there is some opponent sorry, OPS is, I feel it is something like opponent scores and opponent on base percentage, opponent slugging average, opponent OP. So I'll not go to that part, but then we also have the data whether they make it to the playoff or not. So these are also so if it is one, then that means that that particular team, that particular year, that particular league, they made it to the playoff. Zero if it is not. Now I'll use some sort of okay, so I'm making you to sit in the position of Paul de Podesta. So he was there in the team, he was appointed before 2002. So if you take the data set before 2002, then I have the only data from 1999 to 2002, and we have the similar data but reduced set. And now I just want to see that how many games are needed to make it to the playoff. Now I just make a some ggplot r plot. So in y-axis you have the team names. So these are the name of the teams, and then in the x-axis we have the number of wins that we have for each every year. So for every team you have three data points. Huh. So basically Oakland Athletics is basically, you can see this OAK, that is the Oakland Athletics. You have the one data point here, one data point here, one data point here. And why three data points? Because 1999, 2000 and 2001, because we are dealing with the data before 2002. So we have only 3 years of data, and that is basically how many matches they win. So that was the each dots are total number of matches they win. And also, the if it is blue, that means that they made it to the playoff. If it is red, then they did not make it to the playoff. That is the distinction. Now the question is that how many wins are needed, and this is where from the plot you can take any line that I mean that can have a good blue line coverage on the right hand side. So what Paul did was that he proposed that it would take 95 games, and that's why I put the slash bar on the 95 to make it to the playoff. But you can take 92 also. I mean, there is no embargo on that, but I take 95 the way Paul took that. Now the thing is how many runs needed to score for and against to win that so many games, and this is where things get interesting. So this is one particular cybernetics founder, Bill James. He hypothesized that there is a stable relationship between total number of run difference in a season for a team and the number of wins. Now, if I just find the total number of run difference for every team and I regress W to that, then I will have a very close linear relationship for number of wins to the total amount of run difference. And you can see very nice good fit of linear regression. So in order to make 95 number of wins, if you put that in a regression line, which is basically this particular line in X, if I want to have 95 here, total number of run difference I need is basically this. And that is literally 142, close to 142. We need to have every team in order to make it to the playoff, the run difference has to be 142. Now the question is that how one can make that amount of run difference. So run difference means that total amount of runs scored and minus total number of run defended. So now I'll go little fast. So basically for every team, the total amount of runs scored is regressed on this variable called OBP, slugging average, batting average, and OPS. And then we'll see, and I'll just show you that for OBP, the goodness of fit test is like 83.98%, which is quite good. OBP is a good predictor of total amount of runs scored. Slugging average is 76%, around 76%, which is also very good. But you see the batting average, which is the traditional metric that people used to take to scout players, it is 66%. It is not as good as the other two metrics. So we'll try to remove that. We just go with the OBP and slugging average in order to predict the run score. And if I show you this regression, then you can see that adjusted R square is close to 92%, which is really good. But now, what happens if I add OBP, SLG, and also batting average? Because more is merrier, right? So that is the traditional idea. If we add another covariates, it will make the fit better. But what happens is that this is where this knowledge about adjusted R square comes in handy. You will see that it will also fit a line. The multiple R square incrementally increase from 90, previously it was 92.19% to 92.22%, so it increased. But see, this adjusted R square, it decreased from 92.01% to decrease to 91.95%. So addition of this batting average to the existing is does not is not a good choice. So you just go ahead with OBP and SLG, and this is exactly what Paul did back then in 2002, in order to regress total amount of runs scored. Now I'll make it very fast. So remember, total number of run difference is total number of runs scored minus total number of run defended. So the formula for winning comes to finally basically that basically the formula of winning is we have the regression line, that's something constant, 0.099 multiplied with the total number of run difference, and then RS has a regression line with OBP and SLG, and you can do the similar analysis for the RA, which is a run against, with respect to OOBP and OSLG. So this is basically, so now if we have the information of OBP, SLG and OOBP and OSLG, put it into the picture, and you can predict total amount of win that particular team can make just by using simple linear regression. Now I'll come back to the particular question that we started with. So how do you select the those 5 players that we had there? So we have this OBP and SLG score for every players, and we have their salaries. Now, remember, OBP and SLG are crucial for runs scored. We take this coefficient, and these coefficients are coming from the least square estimate of the linear regression that we have done. So now use this coefficient, multiply that with these two quantities, and you get a efficacy score for every player. And if I do that for all these 5 players, we get this scores here. And based on this score, you rank these players. So what is the highest score? 1981, which is the Eric Chavez. Sorry, I'm making a mistake. No, I think I'm right. So Eric Chavez got the highest score, and his salary is 1.065 million, and your budget is 1.5 million. Remember that? And the number 2 is basically this guy, Jason Giambi, but his salary is 1.2 million. So you can see that money does not equal to efficacy always. So you cannot take these 2 players because it will exceed your budget. So what is the next best choice? So third person is this guy, Carlos Pena, and his price is 300. So what you can take is that instead of taking number 1 and number 2, you can take number 1 and number 3. They are coming within 1.5 million, and that is exactly Paul did back then. And that is precisely the point that I'm trying to make, that using simple linear regression, you can make efficient choice of selection of players based on the data that you have, and that is precisely what sabermetrics is, and that is exactly what Paul did. And I'll stop here, and I'll take any question that you may have. Yeah.
Okay, thank you for your presentation, Abhishek. If anyone has a question, we can have 1-2 quick questions.
Yeah, I'm sorry about the
That's
initial
fine.
things. Yeah.
Well, one quick question, which is
Yeah,
very
go ahead.
trivial one, is that have you tried this in any other context? Like maybe in politics, you can have these political parties, they want to make a
Absolutely.
team of
Political.
MPs
Absolutely.
and the history of
Yes.
the, or maybe in chemical reaction network, I don't know.
Chemical reaction network is tricky because
Because you
we
have
don't.
several reactions, you want to make a team of reactions, and then to instead of winning, losing, maybe multi-trinity or not multi-trinity or something like that.
Yeah, that is the thing is that let's talk about politics. So there can be many things, like how a person is articulate, how much different, like if in an educated, I mean good, I mean developed countries, articulation and speech, that matters a lot. So those kind of information can be encapsulated with your data, and that way, and you don't have to do linear regression all the time. Sometimes non-linear regression, other complicated stuff will also work. Linear regression is simple stuff. Using simple stuff can make you also get to the very far. So that is the main lesson or key takeaway of this story. But you can use it in different contexts. Mhm.